Hello everyone, good morning. Today I will review a paper titled in Exploring the Synergy of Grammar-Aware Prompt Engineering and Formal Methods for Mitigating Hallucinations in LLMs. Here is about the introduction of the paper. It establishes the issue of hallucinations in LLMs, a widely recognized problem in artificial intelligence research. It explores some innovative methods for grammar awareness and formal systems to address the problem. Here is about the objectives. The first purpose of the paper is the synergy of two approaches, grammar and formal methods, which offers a promising multidimensional solution. It creates the potential to bridge gaps between linguistic understanding and computational logic. Now I'm going to the next slide. Here is about the methodology. First of all, we will have to identify the problem. Um, in this step, the paper shows that we have to analyze the steps of hallucinations in large language models, LLMs, such as factual errors, logical inconsistencies, or grammatical mistakes. And in this step, hallucinations will be categorized into subsets such as factual versus creative to target specific solutions. And in the next step is here is about grammar hour prompt engineering. Designing grammatically accurate and contextually relevant prompts for LLMs and developing the rules for templates for constructing prompts that will avoid ambiguity and that will reduce open-endedness that often leads to hallucinations, and it will test the effect of prompt variations such as structured question-based prompts versus free-form text. The another step is formal methods integration. Applying formal verification techniques to ensure logical consistency in LLM outputs, such as using symbolic logic to verify claims made by LLM, employing constraint solving techniques to limit outputs within defined parameters. Incorporate domain-specific ontologies or knowledge bases to validate factual accuracy. The another step is data pre-processing. In this step, data sets will be verified using grammatical correctness and factual content or training for training and evaluation, and then ensuring the diverse of data source and for robust performance across languages and domains. And the another step is implementation workflow. Here, um, here combination will be ensured in grammar-aware prompts will formal methods in a pipeline, such as generating an initial response using grammar engineering prompts and validating the response against formal rules for logic and factual consistency, and then adjust or regenerating outputs based on validation feedback and automating the feedback loop for dynamic prompt adjustments. Now I'm going to the next slide. Yeah, and the next step is about evaluation metrics. Here we will evaluate the grammatical correctness, logical consistency, factual accuracy, and finally we will compare the performance with a baseline model using unoptimized prompts. And the last step of methodology is experimentation and testing. Here, experiments will be conducted on multiple LLMs to generalize findings. For example, GPT models, BART variants, and here domain-specific database will be used to test the scalability of the approach. Here is about the outcome of the methodology. A combined system that leverages structured prompts and formal logic to minimize hallucinations in LLM outputs. And next, insights into the interaction between linguistic structure and computational formalism. Now I'm going to the next slide. Here is about the weakness or gaps of the paper. Here is a limited exploration of computational overhead introduced by these methods, lack of discussion on user-specific customization of prompts, and potential challenges in scaling formal methods for large and real-world datasets. Here is about the future work which can be done. Application of the method in multimodal systems combining text with images. Then testing on domain-specific LLMs, biomedical or legal LLMs, and then integration with reinforcement learning for real-time improvement. Thank you everyone for listening me.